Thank you. Thank you. Welcome here at this talk. My name is Michal Mohlava, and let me introduce myself. I am software engineer at H2.ai, which is the company in Silicon Valley. And before I was doing a lot of research. I finished the PhD. I went for the postdoc to Purdue University, and then I finally and H2AI, and like 4 years ago almost. And what is H2AI? It is Silicon Valley company, which is located in Mountain View. It was founded by these guys, Sri and Cliff. Sri is the guy who was working at DataStax and Platfora. Cliff is one of the developers from the Sun, and he was involved in just-in-time compiler development. He's one of the key person who developed that piece of the JVM. And he has really great insight to the performance and low-level hacking. And there is also a team of the software engineers, data scientists, and a lot of people. We are still growing, and we are also backed up by clever people from the Stanford. They are our advisors who are helping us to develop our product, which is called H2O. And the H2O is, in fact, in-memory, open-source machine learning platform. So let me go a little bit to the details of the H2O, how we did that piece, and what is the connection to the Spark. So what we did in H2O, we built full stack from the scratch. We built our own distributed memory KV store. We built execution engine on the top of this KV store. And then on this low-level layer, we built machine learning library. The library itself involves a lot of algorithms: deep learning, gradient boosted machines, random forest, k-means, GLRM, PCA. We have a lot of data managing utilities. And the key point of this library is that it's fully distributed and fully parallelized. And we really focus in the company on this piece, on the machine learning aspect. And that's why there's also a reason why we develop this platform from the scratch. And all these functionalities are published by different APIs. So the whole platform is built on the top of JVM in the Java. So we expose Java API and Scala API by default. And also we built REST API. And the REST API enable us to connect different technologies. So we provide clients for the R, for the Python, and also interactive user environment. And how we can run? We can run in standalone mode. So you can launch H2O on your laptop. You can launch H2O on your bare hardware in the office, on the local machines, on local cluster. We can, of course, run on the top of the Hadoop, on the top of the resource managers like Yarn. And, of course, we can run on the Spark. So I would like to introduce Sparkling Water, which is, in fact, the way how you can run this full stack of machine learning algorithms on the top of the Spark. So what is Sparkling Water? In fact, it's transparent integration of H2O to the Spark ecosystem. That means that you can use H2O algorithms with Spark data structures, with Spark RDDs, with Spark data frames, and vice versa. So if H2O algorithm provides some data, we call the data, the output of H2O algorithms is called H2O frame. You can transfer or publish this H2O frame as RDD or as data frame to the Spark. And all this idea was motivated by people having already existing Spark pipelines, doing a lot of data managing, and they would like to explore more machine learning capabilities. So they wanted to use our, let's say, deep learning on our GBM model builder. So that was the first idea why we built Sparkling Water. So let me show a few typical use cases how people are using Sparkling Water. So first use case is really easy. You have data source, or people as data source, and then they have already existing data management pipeline developed with the Spark. So they have a lot of transformation, data extraction and data cleanup. And then at the end of this pipeline, they will build a table, RDD or data frame of the numbers, and they plug H2O there, and they build a model. They build, let's say, a random forest model or a deep learning model, and then they use the model to make some predictions about another data which are prepared by the Spark. So this is a very simple use case, but people using this H2O in this way. The second use case, it's not so common, but people also trying to use H2O in this way, and H2O is, in this use case, used as data loader or data transformation tool. So we put a lot of effort to our parser. So we tune the parser on a lot of customer data, a lot of messy data. So you can read without any tuning. It can read a lot of data, and it can figure out the types of the columns. It can figure out the notion of the missing values, and all these small tuning pieces are also configurable. But we put a lot of heuristic how to do the best job, and people just put the data to H2O, and it just load the table, and people are in the most of the cases happy. And then of course in H2O we can do some data management operation as well. There is small difference from the Spark that H2O has different execution model. So we are not building, let's say, execution graph as Spark is doing. We have eager execution or eager modification. That means that if you ask H2O to do something, let's say some update in the table, it will do that. It will not build any execution graph. It will just update the table, which is quite cool. Let's say if you are doing some, if you have big data and you just need to modify small pieces of the table, you just launch few tasks around the cluster, and they will just modify these pieces in the table, and then you just continue. So this is another use case how people using H2O. And the last use case, the most favorite use case, in fact, includes two pipelines involved where H2O is involved. So the first pipeline is offline training pipeline. So that means that people load data, they data manage data, transform data, and then they build H2O model at the end of the pipeline. So the first pipeline producing H2O model. The second pipeline is in fact streaming pipeline. So they have some kind of the streaming technology like Storm or Kafka or Spark streaming, and they export the model from the H2O in the form of the code. So this is one of the features which we support in the H2O. So they can export the code in the form of the code. They can export the model in the form of the code, and the code itself is independent on H2O. It's really pure Java code, and they just plug this Java code to the pipeline, to the streaming pipeline, and then it's running and classifying or providing the risk scores for the incoming events. So which is quite cool, and people like this feature because it allows them to build almost real-time pipelines, because these models are really generated with for the best performance. And this is my favorite pipeline, and as I mentioned, whole project, H2O, also Sparkling Water are open source. So if you go to the GitHub of Sparkling Water, all these examples are inside the GitHub. So let me go a little bit deeper to the Sparkling Water. What is inside? What is running under the hood? So let's imagine that you have a Spark cluster. So there is some executors, the nodes which are executing the computation task, and there is a driver which is driving the computation. And in the most cases, you create a Spark context to create a Spark cluster. And if you like to use the H2O, you just create H2O context. So we really try to be transparent to the Spark and follow the same terminology, the same notion of the API. And if you create the H2O context, it will initialize H2O services on each executor in the Spark cluster. So from that point, the H2O is sharing the JVM with the Spark executor. That means that H2O can see Spark data, Spark can see our data, and we can live in the same JVM and cooperate. And from that point also, we can run any H2O algorithm and generate data, generate models, and access them. So if I will go a little bit deeper and explain how it works internally. So imagine that you have like one executor and you have data loaded in the Spark data frame and also in H2O frame, in H2O data structure. So direction from H2O frame to the data frame is the transformation, or execution of the transformation is really easy and cheap. We just create a small wrapper around our data structure, which looks like RDD, and Spark is happy. The opposite direction is a little bit more interesting and a little bit more difficult. I mentioned that in H2O we are using our own memory store, our own data structure, and our own execution engine. So that means that right now we cannot use the Spark support to execute our tasks. So what we are doing in this transformation, so if you have data in Spark data frame and you would like to publish that as H2O frame, so we need to read the data in the data frame and transform them into the form of H2O frame. That means that we will do some kind of like duplication of the data in the memory. But on the other hand, we are doing a lot of tricks to avoid that. So we are doing data compression on the fly in the H2O. So let's say if we have numeric data, we can see that we can really compress data like by 40% in comparison with the data stored in the RDD. So we are doing like a lot of tricks to keep the memory footprint low. But of course, if we are sharing the same JVM with the Spark, you have to like keep balance and a little bit tune the Spark memory settings. So I think there was enough about like speaking, and let me show you a quick demo how you can use the sparkling water. So I will switch to the console, and if you go to H2O AI/download, there is a download page of sparkling water, and you can download the pre-built sparkling water package. Or we also publish a Spark package, so you can just just use the Spark package identification like Maven coordinate to reference our sparkling water package and just run Spark by itself. So what I will do in this case, I will use pre-built package which we providing on the download page and run Sparkling Shell. The Sparkling Shell is, I will a little bit make it bigger. It's just classical Spark shell, and it just attached on the class path sparkling water libraries. Sparkling water libraries, in fact, includes all the H2O algorithms and all the H2O support. So I will just run this piece. It will initialize the H2O. It will initialize the Spark shell. I'm running on the local machine on my laptop on the single JVM. So it's a very simple use case how you can use the sparkling water. So let's wait till the end of the initialization, and I will import the H2O packages, and I will create H2O context. So you can see that I will make it bigger. You can see that we follow really like the Spark notion of the API. And if you have H2O context ready, so let's wait for that. And also I enable debug mode, so you can see a lot of output. And it's the output from the H2O. So H2O started the services, it started the memory store, it started the execution engine, and say, okay, I can see one executor, and this is the IP of the executor. And if you have H2O services running, you have everything which we provide in H2O. So you have also the Flow UI. And Flow UI is, in fact, this H2O environment, how to explore data, how to build the models, and how to make some work with the data. It's of course, as I mentioned at the beginning, is one of the ways how you can access H2O. Another way, I will not show it here, but if you have free time, just you can stop at our booth, K27, and we can show you a demo how to access this cluster from the R or from Python. But in this case, I would like to use H2O Flow. So what I will do, I can type here a command. So give me the status of the cloud. So you can see there is some cloud, H2O service is running, and the H2O services are reporting one Spark executor. So what I will do, I already prepare the Spark Summit East notebook, and I will try to run it. So let's allow me to explain what I am going to do. In each cell in the flow, you can type H2O commands or Scala code. So in this case, I will generate data with help of the Spark. The data will be generated in the way that I will generate 1,000 data points, and each data point represent point in the 2D space with the color and weight. And I generate the data in the form of the chessboard pattern. So like red. I in fact choose the colors red and blue just to see that, but like black, white, black, white. So let me generate this data set with the Spark API, and really in this case I'm using Spark API. I can of course do that here in the Spark shell, but I would like to show you how you can do that directly from the H2O flow. So it finished, status success, and response, okay, data frame. So then the next step, publish that Spark data frame as H2O frame, because I would like to show you the data frame here in the H2O flow. So far, H2O flow cannot see the Spark data structure. So I will publish that data frame as H2O frame. So for this job, I will get reference to H2O context and call the method as H2O frame and print the result. So let's wait, and the status is response, and there is a lot of numbers. It's not interesting, but I will ask H2O, give me the frames, give me available frames. So let's see, there is one frame already ready, already prepared. So let's look what is inside the frame. There are some data and columns. So you can see, you can see that there are 4 columns, X, Y, weight, and color. The first 3 columns are numeric. There are some properties like minimal, maximum value, mean. So we compute all these properties on the fly. So which is really beneficial if you are doing like some quick data exploration, you just load data and you have all these properties ready. We also use these properties to do like a lot of decision inside the H2O. As I mentioned, to compress data, to distribute the data, and to see the shape of the data internally. So then the next step, I will look at the distribution of the last column, of the color column. So you can see that the colors blue and red, they are distributed in the same way, like 50-50. But it was like by default as I generated the data. So the next step, let's visualize the data. So I just wrote here a little function which is in fact taking the data stored in the data frame and just showing them here in the flow. So you can see, let me make it smaller. And close this left side. You can see there is a chessboard pattern. In fact, you can see the lines here of the red, blues that represent the points in the space. And the size of the point is the weight on the point. So, we can quickly load data from the Spark to H2O, look at the data, look at the shape data, look at the distribution, visualize data. So the next step, I will split data to two data sets, to the training and validation. So I will use built-in split frame function of course, I can go directly to the Scala cell and use Scala API of H2O to split the frame, but there is already prepared function of the UI, so I will use that, split the frame. There is, now I have two frames 750 and 25, which contains 25% of data and 25% of data, and let's build a model. So I just opened the, this is the like a wizard. You can select which model we are going to build. I will just simply build simple GBM model, gradient boosted machine model. And I will use default settings, 53s, depth 7, stopping criterion, stop when you can see 10 rows in the leaf, and learning rate, I forget what is the default, 0.1. So that's it. So let's build GBM model. It should be fast because it's a really small data set. I have GBM model, and I can explore GBM model. So you can see this is like training history. What was the log loss during the training of the model? So we report both values for the validation data set and also for training data set. So you can see that the training going down, you know, the model learning data, the validation is going down, but not so fast, so it seems good. Then we have also AUC curve. So this is the AUC curve of training data, not so interesting, but this is more interesting curve, AUC curve on validation data. So it's pretty good, like not the best model, but not bad, like it's better than flipping the coin. So you can see that the model somehow figure out the structure of data. Of course, you know, variable importance, so by the notion how I generated the data, that I use the values y and x to generate the color, then the y and x are the most important features in the model. The less important is the weight because it's just a random number. And also get another metrics which are used, in fact, by the customers. These are all the metrics which I'm showing here are requested by the customers. They would like to see gains, they would like to see AUC curves, they would like to see lifts. And all this stuff you can also, you know, explore here. We, in fact, output all the scoring history, all the technical parameters about the model. And this is a really important fact because you can, if you have all these parameters, it helps you to understand the model and to explain the model later, let's say to regulators or to your colleagues. I also mentioned that we can export the model as the code. So this is the example of the code. So you can see really generated code, a lot of trees, a lot of numbers, a lot of parameters. And this is like really automatically generated tree which represent the model. And as I mentioned at the beginning, it's the model which is independent on the H2O itself. So let's go to the next step. Use the model to make a prediction. So I will invoke this line. It will show me the UI, how to make the prediction. I will close this. Oops. So let me go back. And let's make the prediction. So I will do prediction. I will use the model to make prediction of the validation data. So again, AUC curve. And this is not so interesting because we already saw the AUC curve. So this is, in fact, the values which were cached and all the parameters. But I am interested in the prediction frame. So we generated, the prediction contains the actual predicted value and the probabilities for the both categories. And then I can explore the data in the frame. So you can see blue, blue, red, and the probabilities. And the last step, almost the last step, I need to merge this prediction frame with the actual validation data to have all the columns together. So look at the frame, I merged that together. Oops, I didn't merge that. I didn't execute that. And okay, there is some, I skipped the cell, but I'm running out of time. So let's skip this guy and look here, and we can, in fact, take this prediction frame and make it available inside the Spark. So I will just run this kind of the code, and I hope it will execute inside the Spark. And the Spark, the H2O frame is now available as RDD, as data frame, and I can, call any Spark code on the data frame and give and process the results. So I'm a little bit running out of time, so let me stop here. If you have any other question and if you would like to see more demos, stop at our booth K27. We can show you how to run this stuff inside the Databricks cloud, or as the standalone thing, or from R or from Python, and give us feedback. It's open source. Give it a try. You can try it, and you can make a pull request, and we are excited about people contributing to the H2O and Spark. So thank you very much, and this is the time for questions.
Yeah, so if you have a question, just go ahead and raise your hand, and I'll walk over to you. But in the meantime, I was curious if you could contrast H2O with MLlib.
Yeah. So we are aware about MLlib, and in fact we are still communicating with Databricks from the beginning. Then saying, okay, for us is machine learning the key point. This our main focus, and we can see MLE complementing thing which complements our set of algorithms. So I can show at the booth, let's say, another demo which is using MLlib with our algorithm. So we will, in the demo, we'll be using MLlib Word2Vec to process text data and then feed the output of Spark Word2Vec to the H2O and build deep learning model on the top of results. So we see MLlib really like the complement to our machine learning library. And normally we recommend people, okay, it's it depends on your use case, it depends on your experience. If you are happy with the MLlib, stay with the MLlib. If you need more advanced machine learning, you can try H2O, and you will see how it will scale, and so on.
Great, thanks. Any other questions? All right, I think we're good.
Okay, thank you very much for coming.